Hi there. Thanks for checking out the video. I'm Steve Goldman. I am a postdoctoral fellow at the Space Telescope Science Institute in Baltimore, Maryland. And I wanted to take this opportunity to let you know about an observing program, a joint observing program between SOFIA and the Hubble Space Telescope that's focusing on the symbiotic Mira HM Szigeti. Now, this system had a known outburst in 1975. They expect this is the result of a hydrogen flash on the white dwarf companion that's around 60 AU from the Mira. And the Mira is quite evolved. It has a lot of dust. It has a pulsation period of around 527 days. And with both SOFIA and Hubble, we'll look at this from the UV and the infrared. So with SOFIA, we'll focus more on the dust and the kinematics of the system. And with Hubble, we'll focus more on the gas in the near nebula, but also the shocked emission that we're seeing. So I'll go through each of the observations. For Hubble, we have WIF-C3 imaging in the UV and 3 narrowband filters. The H-alpha, N2, and O3 filters. And what we're trying to do here is study the changes in the morphology of the ionized gas and its known jets. So here I am showing the previous archival images from the Nordic Optical Telescope that were taken in 97, and also with WIF-PIC2, with Hubble back in 99. So we're going to look at the changes of the morphology and compare them to our more recent observations. And we have a much longer exposure for the N2 filter, and that's what I'm showing here on the right. In addition to this, we also have Hubble COS UV spectroscopy, where we're looking at these high ionization lines. And so we have a long baseline of observations for this. So these are from 1982. And the goal is to probe the evolution of the shocked gas using these. So you can see some of the similar lines in our new spectra. And for this, we have 3 different pointings, 1 on the central source, and then 2 a little bit farther out. So these are our Hubble observations. We also have some upcoming observations with SOFIA. So first we have observations using XEs. This is high resolution infrared spectroscopy. And so we're going to be focusing on the rho vibrational line of water, 4 of them in particular. And when I say higher resolution, we're talking about a resolving power of 50,000. So a resolution of around 6 kilometers per second. And we'll use that to study the kinematics of the wind and also the accretion flow. And then lastly, we have upcoming SOFIA IR imaging and GRISM spectroscopy with forecast. And so we'll be doing imaging in each of these gray and orange filters on the top, and then GRISM spectroscopy in those green shaded regions. So on the bottom, I'm showing a previous ISO observation of the system from the late 90s, as well as a couple of dusty models that we've fit to this system. And what we're going to try to do is characterize the silicate dust and use the ionic emission lines you can also see in the previous ISO spectra to probe the nebular emission and see how it's changed over the last couple of decades. So with this joint program, we hope that it anchors future studies of this really interesting system. It has a lot of stuff going on, from jets to outflows to dust production and accretion. And so we hope that people use this data. It's publicly available. And you can see there's a link there where you can access the data and also the white paper. And so we really encourage people to take use of this data. And if you're at all interested in this program, please contact me there. There's my email. And I also wanted to advertise talk that I'm giving on M31, the evolved stellar population there. So thanks for listening.